Distinguished guests, dear judges,
ladies and gentlemen,
we are honored to deliver our presentation here.
My name is Yao Qingqing.
My name is Wei Min.
My name is CHN060.
My name is Fang Chen.
My name is Jin Xiaochun.
We are from Dafeng City, Jiangsu Province of China. It's a very special city. Do you know why it is so special?
Because Dafeng City is not only a land of wonder,
But also the hometown for a unique and a rare animal,
the Davis deer,
there is also a dreamlike wetland forest.
which maintains a perfect primitive ecology and with hundreds of different bird species.
We will be very honored to invite you to visit our city.
We are a QC Circle from State Grid Corporation of China. As the largest public utility in the world, State Grid takes investment, constructing, and operation as a core business. For the past 20 years, we are the only company in the world who has never had a large-scale blackout.
Our circle consists of 10 members, of which the department is responsible for the operation and the maintenance of substations in our city. For the past few years, our circle's project have achieved 1 national award and 2 periodical awards.
The project we are delivering today is research and implementation of intelligent device to suppress the frequent dither of teleindication. Why did we choose this project?
Firstly, we need to understand what the teleindication is. The teleindication refers to the remote monitoring of the real-time system of power grid, while the teleindication signal reflects the status of the primary electric equipment in the substation.
When the teleindication occurs frequently, it sets off our monitoring arm and causes insert information. The dispatcher cannot analyze and handle the signal timely and correctly, which brings a great threat to our safety production and custom equipment. How did we deal with the teleindication dithering before?
We adopted 2 approaches. Our first approach is for operators to eliminate defects on site. However, as a company owns 34 substations and the distance between every substation is 68 kilometers on average, it takes about 109 minutes for 6 or 7 persons each time.
The second approach is to let the departure share the master station manually, but it cannot solve the problem fundamentally and effectively, as shading the main station will also affect the transmission of other normal signals. Therefore, we need a new method or develop a new tool to solve that problem. For this purpose, we brainstorm and discuss whether it is possible to realize quick and accurate ways to deal with the teleindication signals by some new methods, such as communication through network, intelligent monitoring, and information transmission.
While the novelty search via China National Knowledge Infrastructure, we found that the Watchdog, an intelligent monitoring system, which was introduced in the discussion on automation equipment in I-Wind power plant of Guodian Nanjing Automation Company, which was very inspiring for us. The first reference point is the system can be combined with the Watchdog program and can restart the monitoring and communication program timely to ensure the normal operation of the system when it is stuck.
The second reference point is the teleindication monitoring system applied by Guodian Nanjing Automation Company. When the dithering happens, the system can delay the signal treatment and reject after the displacement.
Therefore, we put forward the following plan. Let me introduce you the process of goal setting and feasibility analysis. According to the previous demand analysis, we know that the purpose of our project is to reduce the dealing time of teleindication dithering. Therefore, we proposed reducing the time from 109 minutes to 20 seconds as the target of our project. Is that possible? we have the following resources.
In addition, through the reference and analysis of other cases, we use the similar intelligent network technologies to deal with tele-indication tethering, which reflects to the same time characteristic parameter. According to the calculation, the time for solving that problem is less than 20 seconds, which proves the feasibility of our target.
After our goal was set, let me introduce you our plans for program selection and how we determine the best solution. Through brainstorm conference, we propose solutions of different levels and make a decision from the first and second level program by considering the function of the device. Let me show you one by one.
Firstly, we choose the full signal screening method. There are 3 comparable screening solutions as shown in the slide. By the comparison of the screening accuracy, time, and cost, we find that the screening through multiple points will cost less but result in good accuracy. So we choose this solution.
Then we choose the starting mode of overflow memory to deal with 4 signals. We evaluated 3 solutions on the basis of the success time, cost, and time. And finally, we selected the start of logic as our way to start.
The third step is to select the approach for the prepositive impedance transferring. And the result shows that the prepositive impedance transferring for shielding cache costs less time with higher success rate. So we choose this solution.
Step 4, we compare transmission success rate, transmission time, and cost for the selection of signal transmission. We eventually decided to use FPGA, which is the programmable network circuit transmission, as the way of signal transmission. At this point, the preparation of first-level solution is completed. After that, we started to decide the second-level solution. By comparing the connection of 3 kinds of circuits, we decided to use network interface connection circuit for its high accuracy and anti-jamming capability. So far, the best solution is shown in the figure.
We have just introduced you the processing of determining the new method, and then we made a detailed plan by 5W1H form and then implement it according to the plan. Firstly, we draw corresponding circuit diagram and then carry out the simulation through multisim. After that, we test the accuracy of the screening through multiple points. The accuracy is 100%. Our target is fulfilled.
Then we designed a flowchart for the start of logic and wrote a program according to the flowchart. However, we find that this method cannot meet our demands, so we replanned and wrote a new one. We tested the success rate according to the procedure, and it reached 100%.
Step 3, we designed a RAM division for the prepositive impedance transferring for shielding cache. And the situation is shown in that we tested the success rate of shielding, and the result reached 100%.
Before the implementation of Step 4, we proposed various solutions for countermeasures. We draw PDPC diagram and network interface connection circuits, set the relevant files of dispatching system, and purchased the 3 main kinds components. After that, we made a circuit board according to the diagram and test the accuracy and anti-jamming capability, which also reached 100%.
Finally, we assess board and test the device as a whole. The equipment display is shown in this slide. And then we assess board procedure is shown in this video. After that, we verify the signals and test the success rate. The success rate is also reached to 100%.
After the implementation of our countermeasures, we tracked 7 times of frequent dithering from September to October of 2016. The dithering time has been reduced from 109 minutes to 15 seconds. The time, much shorter than the set values, proves that our countermeasures are effective.
Using the device saved the cost by $2,844. Such a device was also successfully in the monetary device produced by Guodian Nanjing Automation Company, bringing certain social benefits.
In December 2016, our device received acceptance of expert groups of State Grid Corporation and was fully promoted to power industry. Guodian Nanjing Automation Company also compiled instructions and made a good example for other companies in mass production of special equipment.
In order to standardize our innovation outcomes, we complete operation instruction as well as technical specification and conduct continuous improvement. Moreover, all departments cooperate with each other to calculate relevant regulators and standards to follow.
Finally, let's review what we have presented and our innovation points.
Through innovation activities, our circle not only solved the problem of long processing time for frequent gathering of telecommunication signals, but also ensured the safety of people, power grid, and equipment, and the innovation and cohesion of team members were further improved.
Our project has greatly improved the development level of all members. Next, we will develop a device to improve the transmission correction of DC system signals to solve the problems of missing DC signals. Innovation inspires infinite growth.
Innovation drives the development of power grid, and we will never stop innovating. Let's unlock our imagination through quality control circle.
This concludes our presentation.
Thank you for your kind attention, and we wish you